Hi guys, in this video I want to look at what is current. Current is the flow of electrons in the same direction in a closed circuit. When electrons are randomly moving in different directions, there is no current. When electrons flow, they follow a path called a circuit. A circuit can be either open or closed, but for electrons to flow, the circuit must be closed. A closed circuit is when there is a complete connection between the negative and the positive side of the energy source. Electrons will then follow the path flowing from negative to positive. Electrical components such as lamps are placed along the path so that electrons pass through them. When electrons pass through electrical components, the material making up electrical components will start to behave in another way which we want in electrical. For example, this filament lamp, when electrons pass through it, the filament heats up and produces light. When there is a break at any part within a circuit, electrons cannot pass through, therefore there is no current. This is what we call an open circuit. This is what happens to our electrical switches and circuit breakers, which we use to switch on and off the circuits. They just break or close the circuit. The definition of current states that current is the flow of electrons, but we learned that current flows from positive to negative, whereas electrons flow from negative to positive. This looks like current and electrons flow in the opposite directions, which is not actually the case. This is due to different discoveries about what causes electric current, which were made in the early days of electricity. In the 7th century, there was a discovery of an electric fluid, which was said to be the one that causes electric current. It was discovered that an electric fluid is in excess in positively charged objects and a deficit in negatively charged objects. When the two objects are connected, electric fluid flows from high potential to low potential, that is from positive to negative. From this discovery, current was said to be from positive to negative. In the 9th century, there was the discovery of electrons. Electrons were said to be the ones that cause electric current. It was discovered that electrons are in excess in negatively charged objects and a deficit in positively charged objects. When the two objects are connected, electrons flow from high potential to low potential, that is from negative to positive. After the discovery of electrons, it was found that electrons are the ones that cause electric current, not electric fluid. However, before the discovery of electrons, scientists in the 7th century proposed that current flows from positive to negative, following the concept of electric fluid. Then, after the discovery of electrons, it was difficult to change the direction of current because most textbooks were written and electrical symbols were designed to follow the direction of positive to negative. Till today, the positive to negative direction is accepted as the general direction of current, but it has nothing to do with the electrons. We now have conventional current and electron flow. Conventional current is current from positive to negative. The term conventional on conventional current conveys that this is the direction of current that was generally believed before the discovery of electrons. Electron flow is what takes place, which is from negative to positive. Both electron flow and conventional current, whichever used, give the same result. When doing electrical work, know which current you are using. Electron flow is good when understanding how electronic components like diodes work. And conventional current is good when doing electrical calculations, because you will be mostly working with the positive numbers. We have two types of currents that are direct current and alternating current. Direct current is a type of electrical current in which electrons flow in only one direction. Alternating current is a type of electrical current in which electrons change the direction of flow due to change of polarity. Electrons always flow from negative to positive. When polarity changes, electrons also change the direction of flow so that they continue flowing toward the positive polarity. In direct current, there is no change of polarity. That is why electrons flow in only one direction. The changing of polarity in AC can be caused by moving the magnetic field across a conductor, or more easily by rotating the magnetic field covering conductor coils. Alternating current works at a certain frequency. Frequency is the number of cycles completed in 1 second. A cycle is when the magnetic field rotates back to its initial position. Frequency is measured in Hz, for example 50 Hz. This means that the magnetic field rotates 50 times in every second. Most countries use 50 Hz while others use 60 Hz. Current is also defined as the flow of charges, since negative charges found on electrons are the ones that cause electrons to move. Current is measured in amperes using an instrument called an ammeter. To measure current flow in a circuit or passing through a certain electric component, an ammeter is connected in series with that component. Like here, the electric component is a light bulb, so that all electrons that pass through the light bulb will also pass through the ammeter and be counted. The ammeter counts the number of electrons passing through it in every second and displays them in amperes on the screen. 1 ampere is equal to 6.28 quintillion electrons passing through any point within a second in every second. Looking at how current is measured, we can see that when measuring current, we are finding out the number of electrons passing through any point within a second in every second. It is like we are measuring the rate at which electrons are passing through any point within a second. We can best define current as the rate at which electrons or charges flow. Okay guys, this is what we have in this video. I hope you enjoyed it. See you in our next videos.